Hello students, welcome back to our channel. I am Anisha, your maths faculty for class 12th. In previous video, we have started the question of NCERT book of this chapter, continuity and differentiability. Let's move ahead in the list of these questions. So today we will start with question 4 of exercise 5.1. Okay, what we have to do in this question, we have to prove that the function f of x is equals to x raised to n is continuous at x equals to n, where n is a positive integer. Okay, so to solve a question, I have a rule that always write the given condition, then write what you have to do, then you easily get your roadmap. So always write this given condition. So our given condition, we have a function that is f of x is defined as x raised to n, and what another thing we have given that n is positive integer. N is positive integer. Okay, now what is to do? Well, we have to prove that f is continuous at x equals to n. So how we like check the continuity of a function? We know that if f is some function, we have to check the continuity at x equals to a. We must find it's like f of a. It must be exist. It must exist, and its limit value, that is limit x tends to a, it also must exist, and they both should same, that is f of a should be equals to limit of x tends to a f of x. Then we say that the function f is continuous at x equals to a. So let's do the same thing here. So for x equals to n, where n is as n is a positive number, positive integer, so n raised to n is a well-defined number. It is a well-defined real number. So you can see f of n is nothing but n raised to n. It exists. Okay, now let's check what it is limiting value. So this is limit of x tends to n f of x. So this will be limit of x tends to n x raised to n. So this limit will be n raised to n. As you can see, the function value and the limit value both are same. From here, what we get that the function f is continuous at x equals to n. This is what we have to do. Okay, let's move to the next question. Okay, this is question 5 of this exercise 5.1. Let's read this question. First of all, whenever you are doing any question, read the question carefully, write its given condition, then write what you have to do, then just try to solve it. You can easily, like you have a direction to solve the question. Okay, just now we start the reading the question. What is it? Is we have to find is the function f is defined by f of x equals to x for x less than equals to 1. Okay, for less than equals to 1 it is defined as x, and for greater than 1 it is defined as 5. We have to check whether it is continuous at x equals to 0, at x equals to 1, and x equals to 2. Okay, we have to check the continuity of this function f at these 3 points. Okay, let's begin with okay, first, as in introduction video, I have also said that you can check the continuity of the function by using its graphical definition. Okay, I will explain you here also. What is graphical definition? Graphical definition is that the function is said to be continuous if you like just make your graph without lifting your pen at that point. Okay, then you can say the function is continuous at that point. Let's see. First, we will make its graph. Okay, this is our x-axis, this is our y-axis. So what it is defined as? It is defined as for less than, so it is defined as for less than, let's say this is 1. Okay, so here it is 1. It says that for x less than equals to 1, it is defined as x. That means till here, so at 0 it is 0. So till here our graph is defined like this. Okay, then for x greater than 1, it is defined as 5 value. Its value is 5. So let it is 5. Say this is 5 by scaling. So it is defined as for more than 1, it is defined as it's take the value 5. So here it is open circle, right? Here it is open circle. Then the graph is like this. As you can see, the function is defined as till before x1. That means whenever x is less than equals to 1, the function take the value x, and after 1, that is for x greater than 1, it takes the value 5. Okay, as you can see, we can make easily where we have to check the continuity. We have to check the continuity at 0, this is our x equals to 0, this is x equals to 1, and say this is x equals to 2. So as you can see, I make my graph without lifting in, like we have find an interval. Okay, I will tell you the definition once. When we say the function is continuous graphically by at a point, if you can find an interval such that in this interval you make your graph without lifting your pen. Okay, take this as an interval. You can see in this interval your function value is this. I will change my pen, okay, to explain you in better way. So for this interval, your graph value is this. You make your graph without lifting your pen. Now at x equals to 2, take this interval, take this interval. So here you can see your function value is phi. In this interval, as you can see your function value, you make your graph without lifting your pen. Now the third one is for 1. If you have take any point, like any small, less than equals to 1, your graph is this. And then for when you just move ahead of 1, you directly jump to 5. So as you can see, there is a jump. You cannot make your graph without lifting your pen. So you can easily see at x equals to 0 and x equals to 1, function is continuous. But sorry, x equals to 1 and x equals to 0 and x equals to 2, the function is continuous. But at x equals to 1, the function is discontinuous. So let's do it. We just showed this in graphical approach, but let's do it by the proper definition of continuity. Let's begin with at x equals to 0. For x equals to 0, what is its function value? Its function value f of 0, as it is defined as as 0 is less than or equals to 1. So its function value is f of x is x. So our x is 0 here. So this is 0. Now take the limit value. Limit of x tends to 0, f of x. So for x tends to 0, the function value is our x. So limit x tends to 0, this is x. So limit value is also 0. As you can see directly, f is continuous at x equals to 0. Now similarly you can do this for x equals to 2 also. I leave it for you guys as a homework. For x equals to 2, check that it is continuous, or I will say that it is continuous, or just find the value at limit value, function value, then you will see they are same. This is nothing but they are nothing but both of them will be fine. Now I will explain you the when x equals to 1. Okay, when x equals to 1, this is homework for you. Then we will do the our last point, that is for x equals to 1. So here our function value is, that is f of 1. As you can see, our f of 1 for x equals to 1, the function value is x. So that means the function value is 1. Now let's find the limit value. So as you can see, the function is splitting at x equals to 1. Like before 1, it is taking some another function value, and after 1, it takes some another function value, that is 5. So whenever, as you know, whenever we did in the limits also, whenever there is a like splitting of the function, you always find the left hand limit and right hand limit separately. Okay, so do this. So just find first our, what is our left hand limit? Left hand limit will be limit x tends to 1 minus f of x. As you can see, for x less than 1, the function value is x. So limit x tends to minus 1 x. This is nothing but 1. Now let's find our right hand limit. As you know, right hand limit will be limit of x tends to 1 positive f of x. As you can see, for positive, the function value is 5. So that is limit of x tends to 1 positive 5. So its limit value is 1. So as you can see, here from here, that our left hand limit and right hand limit are not equal. So by this, what we get? Limit not exist. Limit not exist. So by this, what you get? As limit is not existing, so if there is no point to say that it is continuous. But like that means what I'm trying to say, if limit is not existing, you cannot check the equality of the function value and the limit value. So by this, what you can say, the function is discontinuous at that point. So at x equals to, by this, what is the conclusion? At x equals to 1, function is discontinuous. Okay, we have did all three, like this we did. This is homework for you, and I have just showed you this one as it is discontinuous at this point. Now let's move forward to the question 6. What is question 6? Okay, what is question 6? In question 6, just read the question first. What is it is saying? Okay, find all the point of discontinuities of f where f is defined by, okay, our f is given by this, and we have to find all point of discontinuities. Okay, what is to do? Find all points of discontinuities. Find all points of discontinuities. Okay. So as you can see, I have also already said you whenever you have a function, as you can see, whenever you have a function, it is splitting in two different parts. Like for x less than equals to, always observe your function. Half of the part is done when you observe your function carefully. As you can see, f of x is defined as, for x less than equals to 2, it is defined as 2x plus 3, and for x greater than 2, it is defined as 2x minus 3. Okay, so in this, whenever your function is like dividing in such kind of way, like it is splitting at a particular point, for less than that you have a different function, for greater than that you have a different function, always use this method that I will show you. That is, always divide in three cases. Case 1, we have did this in, like, I think previous questions, one of the questions also, but let me explain it here also. So case 1 is when our x is strictly less than 2. Okay, and then case 2, when our x is strictly greater than 2, and case 3, always divide in three cases. Case 3 is when, this is case 3, when your x is exactly equals to 2. Okay, so let's start with the case 1. So for case 1, let take any point x in, so that which is less than, strictly less than 2. So take x equals to 8, which is strictly less than 8. That means I am trying to say take a which belongs to minus infinity to 2 open in this interval. We have just started with any point a in this interval. So let's check the continuity at that point. So for that, first we find our function value. Our function value is f of a, that is 2a plus 3. Let's find its limit value. That is, limit value is limit x tends to a f of x. But for this our function value is defined as limit x tends to a 2x plus 3, that is 2x plus 3. So this will be 2a plus 3. As you can see, the function value and limit value are same. So by this, what we can say, that f is continuous at x equals to a. So what we have just seen, that we have started with any point in this interval. We have started with any point in this interval, and we have showed that the function is continuous at that point. So what we have did, we have just said that we have just explained that the function f is continuous for any point x less than 2. Okay, now similarly you will do, I will leave you as a homework for you. Similarly, do the same thing. Just find the function value, just find the limit value, check, and you will easily find that they both are same. So you will say, from here what you can see, that f is continuous for any x strictly greater than 2. Now the last part, I will explain to you, because this is the crucial one. I will explain you this one. So for x equals to 1. Okay, for x equals to 1, for we have to check the continuity. First of all, always find your function value. Our function value is f of 2. F of 2 for x, as x equals to 2 is lies in this case. So the function value is 2 into 2 plus 3, that is 7. Okay, now the limit value, that is limit. As you can see, same thing we have did in the question number 5, right? The function is divided in two cases, like two parts for a particular point. Say here this one is 2. So find your left hand limit and right hand limit separately. So to find the limit, just find your left hand limit and the right hand limit separately. First, what we will find our left hand limit. So left hand limit will be limit x tends to 2 minus, the function value for this is 2x plus 3. So this, our left hand limit is 7. Now find its right hand limit. So our right hand limit will be limit x tends to 2 plus. For this, our function value for greater than 2, the function value is 2x plus 3. Sorry, 2x minus 3. It's 2x minus 3. As you can see, this will be 2 into 2 minus 3. So this is 1. As you can see, our left hand limit is not equals to our right hand limit. So by this, what we get, the limit not exist. Limit not exist. So when limit not exist, there is not at all a chance to compare this limit value with the function value, because limit itself is not existing. So what we get, the function is not continuous at x equals to 2. So what we have concluded that the only point of discontinuity is I just write in the next page for you. It's only point of discontinuity is x equals to 2, because in the question we have to find the set of all points where the function is discontinuous. This type of question is very like important. You can say that it is an, just I will change a pen for you. This is very important type question because I already said the same thing in the introduction chapter also, that the question where like boards always you always get a question like where we have to find the number of points of discontinuities of a function. So this type of function is always continuous in like in and in this question they are literally very easy. You have to just split your function, check your points in this check your the continuity and at the splitting points. Just this is the thing you have to do. Okay, so that's all for this video. I hope you guys like this video. Do these questions once by yourself. If you have any doubt, just ask me in the comment section. I will try to solve your doubts as soon as possible. Till then, goodbye. Please like, share, and subscribe this video. Thank you.